Alright guys, so today we were supposed to be doing the review day, but I did talk to some, I think, in this hour or next hour, and I think last hour, and a good number of y'all felt that y'all weren't quite ready for this test coming up, or some of y'all were, some of y'all weren't. And it's not that it's a long test, I want to go back over it one more time, just to hit the main key points. The first, and what we're doing today, is least common multiple and inverse variations. The first chapter that we did. We'll do 1 over addition, subtraction, addition and subtraction. We're going to do 1 over multiplication, division, and complex fractions, and then 1 over solving, just to hit them all again. Because this is one of the ones that we've had to go back, I've had in years past, had to go back and redo again. So before we even do the test and then have to go back and do it again, I'm going to go over it one more time, just to make sure that it is, that y'all have got it. And if you've got it, awesome. It's going to make it so that you understand it even more. For those of you who are a little unsure on it, it'll help you guys better understand it. So, and again, what we're starting out with, I think, is one of the ones that y'all at least liked a little bit better than the rest of it, and that is the inverse variation. Some markers. And the inverse variation and direct variation came in 2 main ways. The direct variation was our y is equal to a times x. Or if we got the variable by it, or the letter a by itself, our constant term, we get y is over x is equal to a. And those are really our kind of 2 versions of the direct variation. But really, we can think of direct variation in one other way, and that would be a is equal to x over y. And it still works out the exact same, because we can say our general form y is equal to a times x. And what we can do is divide both sides by a, telling us y over a is equal to x. We've got to multiply by 1 over y, which actually tells us 1 over a is equal to x over y. But a is just a what? Constant term, yes? It's just going to be a number. So really, 1 over a is actually the same as just saying a. Because that 1 over, really, we can suck it into the constant term, making whatever it was. If it was a in this case was 3, well, 1 over a is just saying it's 1 over 3, which is just really saying that a is 1/3, because it's just talking about a constant term. It's just a number. And that's one of the interesting things with constants, that they can actually negate a lot of stuff, like turning it into a fraction. So really these here are all the exact same thing. I'll go on and add that. Or we can say a is x over y. Now the inverse variation, y is equal to a over x, or, oh, it's going to keep scrolling, or if we got a by itself, it's equal to y times x. So, what we're doing first is trying to determine whether it is direct or inverse variation, or neither. And looking at these three here, what can we say about number 1, or letter A? X times y is equal to 5. This would be inverse. Because it does match up to the form of A is equal to X times y. A is equal to X times y. What about letter B? Neither. And kind of the main giveaway is that one, X and Y are on opposite sides, and we have a subtraction sign between it and the number. There's really, with X and Y, whenever they're working together, they're either being multiplied or divided. And if they're on opposite sides, the variable and the number should be either multiplied or divided. We won't have addition and subtraction, especially if they're on opposite sides. Any questions on the first two so far? How about letter C? It is actually direct. Because when we look at this here, we have y and x. Well, y divided by 2 is the same as 1/2 times y is equal to x. So it's our constant term times y, which does make it direct. And if we'd actually multiplied both sides by 2, well, here the 2 and 2 would cancel, leaving us with y is equal to 2x. So it'd make it direct. Any questions on these three here? Let's look at the next three. So the next one we have is that 6x equals y. Would this be direct, inverse, or neither? Direct. Because it's coming in the form of y is equal to a times x. How about number 2? Inverse. Because we have our x times y is equal to a. And number 3? Neither. Because the variables x and y are either going to work together as multiplication or division. We can't have them added or subtracted, and it'd be direct or inverse variation. Any questions on these here? All right. We can go on and look at these last three here, and then we'll move on. The first one would be inverse. Yes. Neither. And then direct. Because it might be tempting to say inverse because we do have a fraction, but in our inverse, the denominator for our inverse, y is equal to a divided by x. The x is in the bottom. It's in the bottom of the fraction. And for inverse, when x and y are on opposite sides, x is in the bottom. Now for direct, y is equal to a times x. Y and x are both in the numerator. So even if we did write it the other way and say a times y is equal to x, which does work for direct, they're still both in the numerator. It just works out that a is a fraction. Any questions on this here? Because I don't think this is the part of the chapter that most struggled with. But it's still good to go back over it again. Now, looking at both of these here, determining whether they're direct, inverse, or neither is really based off of our or what we used as a is equal to y times x, or a is equal to y divided by x. And when we multiply the variables together, we're talking about inverse. And when we're dividing the variables, we're talking about direct. And any of these here, when we use these, we're trying to multiply or divide x and y to see if we get a constant term. So for a, we can multiply, try that first, and do 2 times negative 12. And 2 times negative 12 is negative 24. 4 times negative 6 is, and 6 times negative 4 is negative 24. And last but not least, 8 times negative 3 is negative 24, which tells me that this one here is an inverse. We don't even have to try y divided by x for direct, because if one works, the other one won't. Because any of these here are only going to be inverse or direct. They can't be both. And if we look at the values of x and y, well, the values of x are doing what? They are all increasing where they're all decreasing. So the values of x are increasing away from 0, and the values of y are decreasing towards 0. They're both going away from 0. They're both getting bigger, so most likely if it's going to be 1, it would be direct. So we can try it first. So we can say 2 divided by 1 is 2. And we can say 4 divided by 2 is 2. So it's looking good. 8 divided by 3 is not 2. So it's most likely going to be neither one. And if we did the multiplication, well, 1 times 2 is 2. 2 times 4 is 8. Okay. Neither. The same thing, just a different pronunciation of it. Or depending on how you spell theater. So let's look at 2 more of these here. So we have number 4, negative 4, negative 3, negative 2, and negative 1, and 20, 15, 10, and 5. Do we want to try direct or inverse first? Direct. So we will be doing a is equal to y over x. So here we'll have 20 over negative 4, which would be negative 5. Then we can have 15 over negative 3, which is 10 over negative 2 is, and lastly, 5 over negative 1. So that tells us that this is direct. And if we actually look at the numbers, well, the x values are all going closer to 0, and 20, 15, 10, and 5 are also going closer to 0. They're both decreasing. Because if it's direct, they're going in the same direction. If one is increasing, the other is increasing. If one's decreasing, the other is decreasing as well. So that would be direct. Number 5, well, our x values are 1, 2, 3, 4, and y is 60, 30, 20, and 15. Do we think direct or inverse? Inverse. So inverse would be testing our a is equal to x times y. So the first one we would have is 60 times 1, which is 60. Then 2 times 3 times 20 is, and 4 times 15 is 60. So this here is an inverse. Any questions on these here? All right. Now the other part that we're looking at is least common multiple. And least common multiple, this here really is helpful when we start dealing with our complex fractions and solving, because it tells us what we need to multiply either top and bottom for the complex fractions or the entire equation by when we're solving. And really what we're looking for is the smallest number or expression I can turn each one of these into. So when we look at this here, we have 16m, negative 12m squared n, and 8n squared. So we need a number that I can increase 16, 12, and 8 so that they all become the same. So we're going to need bigger than 4. So we can look at the factors of these here. Well, 16, 32, 48, and then we would have 4, 64, 0, 80, and going on. Now 12, 24, 36, 48, and then it would be 60, 72, 84. Here we have 8, 16, 24, 32, 40, 48. So 48 is the first number that all three of these will be the same. And we would need it to be negative. Because we do have negative 12, we would need it to be negative. Because we're trying to see what's the first thing that will make all these be the exact same. Okay, now we need to look at the variables. So we'll start with m. If I look at all three of these here, in the first one, 16m, we have how many m's? 1, because it's just m to the first. In the 12m squared n, how many m's do we have? 2. In the middle we have 2. And 8n squared, how many m's do we have? M. We're still on m. We'll do n in a second. So I do know that I need at least 1m, but how many do we actually need? 2. Because we're taking the most of each term. And really that's what we did with the number, but it's easier to see that with the variables. Because since the middle one has 2 m's, we need it to have 2 m's. We need all of them to have 2 m's. And then we also have the n. The middle term has 1 n, and the third term has 2, so we need 2. So the least common multiple is going to be negative 48m squared n squared. And that is the smallest number, the smallest expression we can turn 16m, negative 12m squared n, and 8n squared into without having any extra factors. And that's the key, is not having extra factors, because each extra factor we add in, we will have to pull back out at the end. Now there is the chance that there will be extra factors that do show up from just doing addition, subtraction, multiplication, and division. But if we can avoid adding extras, it makes it easier to work with. Any other questions on this here? All right, let's look at this one here. So we're trying to find the least common multiple for 5xy, 15x squared z, and 10y squared. So we can look at the least common multiple for 5, 15, and 10. Because, well, 5 is 5, 10, 15, 20, 25, 30, 35, 40, 10, 20, 30, 40, 50, 60, and 15 is 15, 30, 45. So eventually we would get to 60, and 60 would work, but it wouldn't be considered the least because it has an extra factor of 2. There's an extra factor of 2 in there. So if we were solving, or solving wouldn't be too big of an issue, but especially with our complex fractions, we would end up having to pull an extra factor of 2 out of the numerator and denominator to simplify it. So the least common multiple for 5, 15, and 10 is 30. 30 is going to be the first number that they meet. Well, let's go in alphabetical order. So the first variable that we have is x. So we have x in the first one, x squared in the second, and well, we don't have any in the third. So how many do we need? Squared. We need 2 of them. We need x squared. Now we can look at y. So we have y, no y's, and y squared. So we'll need y squared. And lastly, we need the z. So 30x squared y squared z is the smallest expression we can turn 5xy, 15x squared z, and 10y squared into. And that there would be the least common multiple. It still works. Yes. So x and x minus 2 is the least common multiple. Because if I want to get them to be the same, well, to get x to be the same, we need it to have an x minus 2. And for the x minus 2 to be the same as x, well, it needs another x. I really feel like having the variables or expressions like x minus 2, these here are easier to work with least common multiple, because it's seeing how many of that do I have and getting them all to match. So when we look at this here, we have y minus 2 times y plus 2 as one of our expressions, and the other expression is y plus 2 squared. Well, I do know for sure that I'll need a y minus 2. We also know that we'll need a what? A y plus 2, because the first one does have both of those, yes? Is it missing anything that the other one has? The square. So this here is really telling us what? That we have y plus 2 times, because whenever we square something, it's timesing it by itself. So how many times does it have y plus 2? Twice. So here it has it twice. Here it has it. So how many of them do I need? 2. Because we're taking the most of either one has. Since the one has 2, the other one has 1, we need it twice. Just like with m squared and m, here y plus 2 and y plus 2, we have it twice. So to get this one to be the same, it needs another y plus 2. It needs to have 2 of them. That's actually it. And with the main way I look at most of these here is I will grab one of them, the full expression, so y minus 2 and y plus 2, and see what is it missing that the other one has. Well, the other one did have one y plus 2. It actually had 2 of them, so I need a second. If it already has 1, it needs 1 more. Let's look at the next one here. So here we have x times x minus 1. We have x squared and x minus 1 squared. So as we just saw, x minus 1 squared is really just x minus 1. So what are our terms for the least common multiple that we'll need? We need an x squared. Because the first one does have an x, but the middle one has an x squared, so we need 2 of them for them all to be the same. What else do we need? We need x minus 1. Anything else? Another x minus 1. Yeah, because this is the same as saying x squared times. Because again, when we square, we're just saying it's multiplied by itself. Yep. And those are the same thing. I mean, really, we could do this. Because it's saying that it's multiplied by itself, so the x times x minus 1 times x minus 1 would be the same as this here. But this is a little bit better version. This is a little funky. Okay. Let's look at these two here. Now, one thing we need to be careful of is making sure to check and see if what we are looking at is factorable. Because if it is factorable, we need to factor it. And the x squared minus 1 is factorable too. And we can do that because it's a difference of perfect squares. Now, x squared plus 2x plus 1 is also factorable, and it's a perfect square trinomial. Now, because the 1 is positive, the signs would be the same and match the sign of the middle term, which is positive. Factors of x squared are and 1 and 1 because the factors of 1. And the 1 plus 1 will add together to give us our 2x for the middle term. Now with these here, I normally just grab one of the two because we know we'll need both of them. So which one do we want to grab? So I can grab the left one, so the x plus 1 and x plus 1, because I know I'll need it twice. Since one of them has it twice, we know we'll need it twice. Now we need to see what we're missing. X minus 1. Because we do have an x plus 1 to satisfy the first one. We're just missing the x minus 1. And that's it. And that would be the least common multiple. Questions on this here? Now this one here, we have t squared minus 1, and t squared minus 5, or plus 5t minus 6. Well, the first t is as factored as it gets. It's by itself. Now the t squared minus 1 will factor too. T plus 1 and t minus 1. Now we do need to factor t squared plus 5t minus 6. Well, the negative 6 means the signs are going to be opposite. And the factors of t squared are going to be just t and t. Now we do need to find the factors of 6 that would subtract from each other to give us 5. 6 and 1, and the 6 would be positive, and the 1 would be negative. So what is one thing we know we need for sure? T plus 6 and t minus 1, okay? Because we took it straight from the last one. We know we'll need both of those. Now what does the middle one have that our least common multiple doesn't? T plus 1, so we need to add it. We don't need another t minus 1 because we do have 1. It has 1, so we're good there. Is that it? We just need t by itself. So the first thing these three will become is t times t plus 6 times t minus 1 times t plus 1. And that would be it. Questions on this here? And that is it. So there is a worksheet that would be attached to these here.